question 18, it says, Juan sells gift packs containing soaps and candles. Matrix C shows the contents of a large gift pack and a small gift pack. Find how many more candles are in a large gift pack than a small gift pack. So these are the values that we focus on. Subtract 1 from 4, and 3 is the difference. Then it says the mass of a soap is 120 grams. The mass of a candle is 60 grams. Find matrix M. And matrix M represents this information. Find matrix N. So N is equal to C times M. So let me just write that over here first. 6, 2, 4, 1, and 120 and 60. So what we're going to do is we're going to multiply these two matrices, and the multiplication is going to be like this. This gets multiplied with this, and this gets multiplied with this. So basically, it's going to be like 6 times 120 plus 2 times 120, 4 times 60 plus 1 times 60. And that is going to equal to 720 plus 240 and 240 plus 60, which is 900 and 300 over here. That's right, 960, which is going to be 960 and 300. That is your matrix N. 960, 300. And it says explain what each element in matrix N represents. So the 900 basically represents the mass of contents in the large bag. Mass of contents in the large bag. And 960, sorry. And 300 represents mass of contents in the small bag. Yep. Question 19 says, in the Venn diagram, show the region represented by A intersection B complement, union B intersection C complement. So A intersection B complement is going to be this area. And then B intersection C complement is going to be this area. So that's your shading. Then it says one morning 50 people visit a library. 35 of them borrow a book. 12 of them use a computer, and 8 of them do not borrow a book and do not use a computer. Use a Venn diagram or otherwise find the number of people who use a computer but do not borrow a book. So what we'll do is, let's draw the Venn diagram first. This is for the book, this is for the computer. So 35 of them borrow a book and 12 of them use a computer. 8 of them don't do either. So we have to find the number of people who use a computer but do not borrow a book. So that means we need to find what's common between them and then subtract that from the computer part to see how many just use a computer. And our universal set is 50. So that means 35 minus x plus x plus 12 minus x plus 8 equals to 50. So 35 plus 20 is going to be 55 minus x equals to 50. 55 minus 50 equals to x, and 5 is x. So to find the number of people who just use a computer, we're going to do 12 minus 5, which is 7. That is your answer for this. Question 20 says expand and simplify. So you're going to expand the bracket. 4x gets multiplied with 2x and 5y. And then negative y gets multiplied with 2x and 5y, which means 4x times 2x plus 5y minus y times 2x plus 5y. 8x squared plus 20xy minus 2xy plus minus 5y squared. Collect the like terms. 8x squared plus 18xy minus 5y squared. That is your answer. So let's say simplify x to the power of 12 divided by 8 whole power 2 over 3. So what I'm going to do is I'm going to first convert 8 into 2 cube. That's going to be x to the power of 12 over 2 cube whole power 2 by 3. Distribute the power. So x to the power of 12 times 2 over 3 over 2 cube times 2 over 3. Now, whenever you have power outside the bracket and inside the bracket, always remember that those two powers will get multiplied, not added or subtracted, always multiplied. So we know that 12 divided by 3 is 4, and 4 times 2 is 8. And 2 squared over here, so that's going to be x to the power of 8 over 4. That is your answer. Solve 5x over x minus 3 equals to x plus 4. Cross multiply to get rid of the fraction. X plus 4 x plus 4 times x minus 3. That's going to be x squared minus 3x plus 4x minus 12. Collect the like terms on each term. Collect the like terms on each side and bring 5x to the right hand side as well. X minus 5x minus 12. X squared minus 4x minus 12. Find factors of 12. Factors of 12 are 6 and 2, 4 and 3, 12 and 1. I'm going to pick 6 and 2 because if we subtract 6 from 2, we get negative 4. So we're going to replace negative 4x with negative 6x plus 2x. Then we're going to do factor by grouping. So x times x minus 6 plus 2 times x minus 6. X minus 6 times x plus 2. And x is 6 and negative 2. Basically, we're using factorization of a quadratic equation. Use a quadratic formula, but that will be lengthy for this. Just go for like the simple factorization methods and factor by grouping and get your answers. For question 22, it says y is directly proportional to w square. X is inversely proportional to w. When w equals to 10, y equals to 5, and x equals to 0.4. Find y in terms of x. So if it's directly proportional, y is directly proportional to w square, which means y equals to k times w square. We substitute the values, let's find the value of k. 5 equals to k times 10 square 5 equals to 100k. 5 over 100 equals to k, which would be 1 over 20. Now, next equation is x is inversely proportional to w, which means x is k over w. So what we'll do is we'll find the value of k over here as well. So 0.4 equals to k over 10, and 0.4 times 10 equals to k, which is 4. Both have different values of k, so now this equation becomes x equals to 4 over w. This equation was y equals to 1 over 20 w square. Let me just highlight these. Okay, now we have to figure out y in terms of x, which means we need to get rid of w. So w is 4 over x, and if we replace that in the y equation, that becomes 16 over 20x square, which is going to be 4 over 5x square. And that is your final answer. Question 23 says there are 10 cards in a set. Each card shows either a square or a triangle. Each shape on each card is either green or red. The table shows the number of cards of each type. Ken takes a card at random from the set, notes the color and replaces it. He then takes a second card at random from the set, notes the color again and replaces it. Find the probability that both cards show a green shape. So if both cards are showing a green shape, so that's going to be 7 over 10 times 7 over 10 again. It's going to be 49 over 100. Now, why are we multiplying 7 over 10 twice? Because for the first, when he picks the card first, 7 over 10 was for that. And then when he picks the card again, then the second 7 over 10 is for that. And since both times he's replacing the card, that means the total number is not changing. And 7 is basically 3 plus 4, because it says there's no restriction on the shape, there's a restriction on the color. So the color has to be green, but it can be either a square or a triangle. So we just add the total for the green shapes, which is 3 plus 4 equals to 7. And the total number is 10. In part B, it says Rina takes 2 cards at random from the set of 10 without replacement. Find the probability that both cards show the same shape. So for both the cards to show the same shape and there is no replacement, so same shape is 4 over 10 times 3 over 9, or 6 over 10 times 5 over 9. That is for part B. So that would be 12 over 90 plus 30 over 90, which is going to be 42 over 90. That is your answer. For the next question, it says A is the point 311 and B is the point -5, -5. The equation of the line L is 2y plus x equals to 5. Show that the line L is the perpendicular bisector of AB. So in order for us to prove that, let's find the midpoint of AB first. 3 plus -5 over 2 equals to 11 plus -5 minus 1 and 3. Then what we're going to do is we're going to find the gradient of AB, which would be -5 minus 11 divided by negative 5 minus 3, which is going to equal negative 16 over negative 8, which is 2. Now, if you look at the equation of line L, 2y plus x equals to 5. And if we rearrange it to make y the subject, y would be negative x plus 5 over 2. So the gradient of this line is negative 1 over 2. The gradient of this line is 2. So the condition for two lines to be perpendicular is that the product of the gradients would equal to negative 1. So 2 times negative 1 over 2 is already negative 1. So it meets the first condition. Second condition is that we put negative 1, 3, the midpoint in this line and see whether it lies on it or not. So if we do 2 times 3 plus negative 1 equals to 5, 6 minus 1 equals to 5, and 5 equals to 5, which means yes. So that's how we showed that the line L is the perpendicular bisector of AB.